Everybody say hello.
Hello.
Okay, so today,
Hi,
this is for period F, because we're in period B. We're going to be talking about graphing linear inequalities, okay? But first I want to remind everybody, how we graph lines, okay? Ethan. So we're going to graph y equals x plus 3. Who can tell me what form that linear equation is in? All right, Alex.
That's in slope-intercept form.
Slope-intercept form, y equals mx plus b. Okay, so I gave you some graphs. So just make sure you have your x-axis and your y-axis labeled. So let's go ahead and do that. X and y.
Bless you.
All right, so I go to my y-intercept of 3. And what am I going to do to find with my slope, Lauren?
You use the x, which is 1.
Okay, so my slope is 1, so I'm going to go up 1 over 1, and then I'm going to go down 1 over 1. I've got my 3 points, so now I can graph that line, and I'm going to do my best job to graph a line.
That's really straight.
Okay?
Mine is straighter.
Guys, I really need you to stop, okay? Thank you. All right, so today we're not going to actually be looking at equations of lines, graphing equations of lines. We're going to be graphing inequalities, okay? So there's a couple of things that you need to know. An inequality, when we actually draw the line, you're going to be drawing either a dotted line or a solid line. Okay, dotted lines are used, and they're called boundary lines, and I think I put it right below it. Boundary lines are the line breaking up the inequality into 2 parts. But if it's greater than or less than, so not equal to, you're going to use a dotted line. Okay, so dotted line. Whereas if it's greater than and equal to or less than or equal to, what do you think you're going to use?
Straight line.
All lines are straight.
Oh, a
solid line.
I meant to say solid.
Okay? So that's number 1. All right, so you've already graphed this line. I'm just going to go ahead and, we've already graphed the line, but now we're going to graph it as an inequality. And so this is where it gets a little bit different.
Question.
So hold on, let me get the line drawn. So now I'm going up 3 again. It's the same exact line. It's going to be dotted because it says y is greater than. So up 1 over 1, down 1 over 1, and my line, when I draw it, I'm going to dot it. Now, this is a really good place to use a highlighter if you want to. Like, you can pencil the line in and then take a highlighter and show dots on it, or little hashes on it, so you can see that it's clearly dotted. Okay? All right, but now I have to actually shade, because what this is saying is that there's an area where there's all different solutions. An equation has one solution, the line. An inequality is either going to have solutions all above the line or below the line. So the easy way to look at it is to look at the y-axis. So I look at the inequality, and this says y is greater than. Do you see that? Y is greater. So I look at the y-axis, and I look at the y-intercept. So y is greater would be above that line. So I would shade above the line.
But will it say y is greater?
It does. It says y is greater. Okay? So I would shade above the line. I'm going to show you another way to do this in case that's hard.
So at the end of the dotted lines, you still put an arrow?
You still put your arrows at the end.
Okay.
Okay? All right, now let's look at the other one. I gave you the same line. Hold on, let me finish this. Okay, I gave you the same line, but now I made the inequality y is less than. You always want to read it based on y. So I graphed the line again, 1, 2, 3, 1. Oops, I did my line wrong. So 1, 2, 3. I went up 1 over 1, down 1 over 1. My line's going to be dotted. So I'm going to dot my line going through those points. All right, now I look at the graph, and this says y's less than, right? So I go to the y-axis, because everything you want to do based on y, I go to the y-axis. So from the y-intercept, y's less than, guys, are they going to be above or below?
Below.
Below, so you shade. So that means that any point, any coordinate point in this shaded area will be a solution to the inequality. So that means, I don't know, 3, -3. It's a solution. Anything within the shaded area, okay? Now, because the line is dotted, if it falls on the line, it would not be part of the solution. But if the line were solid and it fell on the line, then it would be part of the solution.
So you would have to shade it like with it?
Well, no, just that's what the dotted and the solid does for it, okay? All right, now I'm going to go through the process very specifically, going through step by step. So everybody go to the bottom of the page, and I said example. And I gave you 3x minus 2y is greater than -4, okay? So step 1 would be, I think the easiest way to do it is to put it in slope-intercept form.
It's greater than or equal to.
It is equal to?
Yeah.
Thank you. I can't see it so well. Okay, so, yes, thank you. So we're going to put it into y equals mx plus b. Now you could graph using the intercepts, but then the shading becomes a little bit more difficult, okay? So go ahead and put that in y equals mx plus b for me.
Do you want to simplify it too?
Yep, and simplify it.
Ooh. Do we flip the inequality?
If you divide by a negative, you flip the inequality symbol. Okay, could someone tell me what they ended up getting? All right, Chi-Chi.
I got y is less than or equal to 3/2x plus 2.
That's what I got.
Is that right?
Yeah.
Did everybody get that?
Yes.
Okay, so step 1 would be to put it in y, put the inequality into y equals mx plus b, then graph the line, okay? Because the line really is y equals 3/2 x plus 2. So you're going to graph the line. So we're going to go to the y-intercept of 2. And then what am I going to do with 3/2, Cole?
You're going to make that your slope. So you're going to go up 3 and
Wow.
across 2.
Good, up 3/2. And then I'm also going to go down 3 and to the left 2. What kind of line am I going to use, Long? Is it going to be solid or dotted?
Solid line.
Why is it going to be solid?
Because it's greater than or equal to.
Greater than or equal to. Good. All right, so then I look at my inequality because now I need to shade. So Sophie, what do I do for shading?
It's less than or equal to, so you shade below.
Good, so that's less than. So where am I going to shade?
Below the line.
Below the line. So I'm going to shade below the line, lightly with my pencil or with a highlighter if you wanted to.
Is it whatever is, whatever the y is, so,
Always read it based on the y.
so
okay.
if it's minus, then it's gonna go under, but greater above.
Correct. All right, so then, one thing that I added here is that you can verify your shading. You verify your shading by using something called a test point. Okay? A test point is any number not on the line. The easiest test point to use is 0, 0, if it's not on the line. So I take the test point, 0, 0, I plug it into either of the inequalities, either the starting or the finishing. Okay? I'm going to go up here, actually, because then it would be 0 is less than or equal to -4, or greater than or equal to -4. Is that a true statement? 0 greater than or equal to -4?
No.
Yes.
Yeah.
Yes.
Yeah.
0 is greater than -4,
Yeah, but it's not equal to.
but it's either.
Okay.
It's greater than or equal to -4. So that's a true statement. So that means the point, that test point, has to be in the shaded region because it made the solution true.
But can't you pick anything?
I always pick 0, 0 if it's not on the line. It's the easiest one. If it made the solution, the inequality, false, then that point couldn't be in the shaded region, so I would have shaded above this line.
Can you give us an example of like what?
We're going to do another one in class in a second, okay? All right, so that's how you do inequalities. I'm going to stop the video at this point.
Thank you.
Say goodbye, everybody.
Bye, Matthew Glenn. Bye, Matthew Glenn.